Okay, so when we wish to estimate the population to lie within a 95% confidence interval with a width of W, the sample size required is given by this formula N. And all that is a rearrangement of the confidence interval formula. So we have, again, we're continuing with the example of height. We have the height of 40 Year 12 students was measured and the observed mean 178, standard deviation 8. Continuing from the above example, how many students would need to be sampled to find a 95% confidence interval with a width of 2 centimetres? Okay, so what it means, right, is our observed mean was 178, and if the width is 2 centimetres, it means we're going 1 centimetre either side of 178. So our confidence interval is going to be from 177 to 179. All right, this confidence interval has a width of 2 centimetres. And the formula that we're going to use is this one here, n equals 2 times 1.96 sigma on W squared. Now, one thing we should notice about this formula is the 1.96. The 1.96 means 95% confidence, and we could change that for other levels of confidence. Very good. So that's our formula. So all we're going to do is plug in the information that we have. We have sigma is 8, and we have the width is 2. We're going to square it. We'll evaluate this. Now, what are we calculating? We're calculating n. N is the number of students that we're going to sample in order to guarantee that width. And I've got 245.8, which is 246 students. Now, n will always be a whole number, all right, because it's a number of samples. If we're sampling that many people, you can't sample 245.8. And the other thing is n will always round up, okay? Even if we had 245.2, you would round it up in order to guarantee that width or less. Otherwise, it's going to be a little bit wider than that, okay? So we always round it up. So it was 245.8. We round to 246. Very good. So that is 9D.2. So let's have a quick look at 9D.3. Now we have the confidence interval that we calculated before. 5.2 is less than the mean, which is less than 180.47. Okay, continuing from the above example, recall the 95% confidence interval was this. Jimmy claims that the true mean height could be as high as 182 centimetres. Is his claim correct? Okay, so from 175 to 180, like you think of a number line, here's 175.5, here's 180, and we're 95% confident, based on the confidence interval, that the true mean lies in this region, and Jimmy seems to think it's 182. Okay, now it could be that he's right, but what does the evidence say? We're 95% confident the true mean lies in here, so the confidence interval does not support Jimmy's claim. So we're going to answer that. Jimmy claims, is his claim correct? No, the confidence interval does not support Jimmy's claim. Interval does not support Jimmy's claim. As it is completely above the confidence interval. Okay, his claim is completely above, and so the confidence interval does not support his claim. All right. Then we have Alex, who claims that the true mean height could be as low as 176 centimetres. Is her claim correct? Well, 176 exists in the confidence interval, therefore the confidence interval supports her claim. Yes, the confidence interval supports her claim. as it lies within the confidence interval. Now notice, we have to be a bit careful with language when we're assessing a claim. A claim is never true or false. A claim either is supported by the confidence interval or not supported by the confidence interval. Okay? So confidence intervals don't guarantee the truth of a claim, rather they indicate the truth of a claim. Alright, so just being careful around language there. There's two parts to it. Make sure you answer the question. No, his claim is not supported. Why is his claim not supported? Because it lies completely above the confidence interval. Yes, her claim was supported. Why? Because it lies within the confidence interval. Really good. So that's enough for us to do exercise 9D2 and 9D3.